Hey guys, this is the last lesson in Unit 7. Unit 7, Lesson 6 is energy. I'm going to be a little bit more in depth on this one because there's some math involved, so I'm going to give you some examples. It might not be the worst idea for you guys to have a calculator handy, even your phone should really work. But I'm going to break this up into parts. So, part 1, we're going to define energy. Okay, so energy is a vocab word, so I'm going to underline it in my highlighter. Energy is the ability to do work. Okay, the ability to do work is basically causing something to change. Okay, so causing a change in its position or its speed, that is what energy is. The unit that we use, now we use the unit of newtons for force. We use a different unit for energy. That energy is called joules. And we abbreviate that with a capital J. So anytime I say a number with a J, that just means how many joules of energy it has. So our unit is joules. We're going to code our notes today so that we don't have to write the same word over and over again. So anytime that I use the code KE, I am talking about kinetic energy. If I use PE, I'm talking about potential energy. And if I use ME, I'm talking about mechanical energy. Okay, so that's just a little code we're going to use so that we don't have to use the same wording throughout the whole video. So I'm trying to adjust, I'm sorry. Alright, so part 2, we're going to start with that kinetic energy. So after we write this, the whole time I'm going to write KE for kinetic. But kinetic energy in short is just the energy of motion. Okay, so anytime anything moves, it has kinetic energy. So it's the energy of motion. So if you're walking, if you're breathing, if your brain cells are moving, it has kinetic energy. Kinetic energy depends on really two things. So it depends on speed or velocity. So how fast something is moving. So with that, that breaks into two parts. So if something is moving faster, that means it has more kinetic energy. If it is moving slower, that means it has less kinetic energy. So depending on how fast something is moving, it will have more or less kinetic energy. And then the second one, it depends on the object's mass. And again, earlier in our gravity lesson, we talked about the difference between mass and weight. So with this one, there's two parts. If you have an object that has more mass, so like a bowling ball versus like a basketball, if it has more mass, then it's going to have more kinetic energy. If it has less mass, that means it's going to have less kinetic energy. So in order to have something that has the absolute most kinetic energy, you would want it to go super, super, super fast and weigh a lot, and have a higher mass. If you want something to have not a whole bunch of kinetic energy, you could have something that has a very, very small mass and a very, very slow speed. Now, if the speed is 0, that means that there would be 0 kinetic energy. And we would know that because of the formula. So we're going to do a little bit of some math here. Okay, so I'm going to move this a little bit. Again, you can pause the video if I'm writing too fast. So our formula for kinetic energy is Ke equals, so kinetic energy is equal to 1/2 times the mass of the object times the velocity, which is another word for speed. Velocity just technically has a direction, but you would square the velocity. Note, we are only squaring the velocity. We're not squaring the mass, and we're not squaring the half. So I'm going to actually highlight this in our notes because this is super important. Okay, and as you guys can see, if our velocity was 0, it would be 0 times these things, which would equate to a 0 kinetic energy. So another way to write this in a more simpler form is 0.5, which is equal to 1/2, okay, times m, which stands for mass, times our velocity squared, which is the same thing as that. So I'm going to give you just one example just to show you guys how you would calculate this. So I'm going to move it a tad. So if I have an object that has the mass of 50 grams or kilograms, I'm going to change it to kilograms, and a velocity of 10 meters per second. And I'm using these scientific units because that's what we would use in our science class. So let's go ahead and go through this. So my first step would be to just plug in the information into the formula. So I would rewrite that as Ke equals, so again the 0.5, which is 1/2, times our mass, so we just drag the mass down into here, so times 50, times our velocity squared. Well, our velocity is 10, but we would have to square it. So it would be 10 squared. So this is what I call the number 1 step, which is just to plug in the formula. Okay, my number 2 step would be to square the velocity. So number 2, we're going to square my velocity. So we're going to do 10 times 10, which is 100, times our original 50, times our 0.5, which is our 1/2. Okay, so once we square the velocity, so we would go from 10 squared equals 100 to our number 3, which is calculate our answer. Okay, so the way we would do that is we would do 0.5 times 50 times 100, and we know that that equates to 2,500. And then the unit that we would use is our unit for energy, which is our joules. So we would do a capital J. And as you guys know, in my class, I make sure you box in your answer. Oops. So you're going to put a line and make that box around the answer so that I know that that is what you found. And you have to tell me what you found, the answer with the correct unit. So that would be a 2,500 joule kinetic energy. A way to make it even more kinetic energy would be to either increase the mass or make it go faster. So that's what we talked about previously. So remember that that J stands for joules. Okay, so that's one example. I'm going to go to part 3, which we're going to move on to potential. So again, if you are not caught up, go ahead and feel free to pause it. I'm going to switch my notebook here.